Our last section on vectors is going to be on component vectors. And this comic really kind of explains the idea of component vectors. As you read that, one person is saying go 10 yards out and 10 yards to the right. The other person says go a 45-degree angle, 10 square root of 2. So if you think about what this comic is saying, the older brother is saying go 10 yards out, go 10 yards to the right. The smarter younger brother says, I'm just going to go on a 45-degree angle, 10 square root of 2. And that's what we're going to be doing. To this point, we've actually done it the way the younger brother has. We've looked at our angle of 45 and said, we're going to go on that angle a certain distance, direction, and magnitude. We're now going to split this up, and we're going to break down our vector into two components. We're going to always break it down into the x component, which is left and right, and the y component, which is up or down. So let's start our notes now here. So if we have a component vector, or if we have a vector, excuse me, we have here, this vector is 5, and the angle is 53.13. And we would just draw it this way, and we looked at this a number of times over various homeworks now. But what we're going to do is, if we would imagine taking this and imposing our axis over top, you can see that what we end up with is we end up with where the vector ends. And we end up with this right triangle. We can convert any vector into a right triangle and then find the x part of that right triangle, in this case 3, and the y part of that right triangle, which is 4. So we can break this vector, the red line, into its two components. The horizontal component, which is x, and the vertical component, which is y. Let me show you why this would be important. If I have this vector, this is a different notation than we're used to. But if I have a vector that ends at 3, 1, and I have another vector that would end at 1, 2, and we would add these two vectors. I would draw my parallelogram. Again, kind of cheating how I can do here. And if I would draw this vector, my resultant vector is right there. Now notice what my resultant vector is. My resultant vector is the point 2, 3. So once I have this as my x and y, all we have to do is add the x's and add the y's. So if I add a vector that went to 4, negative 1, and I had a vector that went to 2, 3, once I had it in my component vector form, I could just add those together and say I get 2, 2. So my resultant is just 2, 2. Now to draw the parallelogram, once I have my x and y, I can just add them. And if you see, if I actually did do that now and draw my parallelogram, you can see that's exactly where I'm at. So what we're going to do is we're going to be given a vector, and we're going to be given some angle, and you can think this is our magnitude. And we're going to break it down into the x and y parts. So we're going to break every vector into a right triangle. Okay. So let's look at an example. We have this vector, west 25 degrees south. So I'll draw this west 25 degrees south, magnitude 10. So this is 25 degrees south, magnitude 10. Now what we're going to do then is we're going to turn this into a right triangle. and I want to find the x and y of my triangle. Now, a couple things. One, always use the x-axis. You always, 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 always want to go to the x-axis. And now I just solved this triangle. This side is 65. If I use my calculator, sine of 25 is y over 10. So 10 sine I get this to be 4.226. And I get this side to be 9.063. So I've broken this down into my x component and my y component. Now, an important thing to understand is look where this is in terms of our quadrants of our normal graph. It's down here in the third quadrant. So when I go to add these, this is really a -4, and this is really a -9. Okay? Because of where they're at. So you need to be careful and pay attention to positives and negatives based on what quadrant your triangle is in. Okay? Let's look at another one. East, 25 degrees south. So east, 25 degrees south. So this is 25. This is 7. Draw my triangle to the x-axis. This is my x. This is my y. Once again, we're just doing SOHCAHTOA. You can once again see that in terms of my sides, what are going to be positive and what are going to be negative. Just from where it's located, I can tell my y-coordinate is going to be negative. And that y-coordinate is negative 2.96. And my x-coordinate is a positive 6.34. Okay. So break it down into the x and a y. Let's do one more. South, 15 degrees east. And the magnitude is 21. So we have this angle here is 15. But it's important to remember that we always make our triangle with the x-axis. Always, always, always. So this side's 21. This angle in here is 75. This angle in here is 65. And then I want to find x and y. So I do SOHCAHTOA again. Sine and cosine opposite over hypotenuse. My x is 8.87, and my y is 19.03. But because it's down, I need a negative. So I found my x's and y's. So let me write those here. So I'm going to do this. Bring this over. And for this one, my x was 6.34. My y was negative 2.96. So if I now want to combine these two, and I want to add these two, all I need to do is add the x's and add the y's. I don't have to draw a picture necessarily. Let me try to show you how this will work. Let's draw a picture. We have 7 east, 25 degrees south. And then south, 15 east, going off the page there. So let's make this one a little shorter. So I go there. Now, we know our x's and y's. So my x's, I have 8.87 and 6.34. If I add those up, I get 15.21. My y's, I have negative 19.03 and negative 2.96. And I get negative 21.99. So what I've done is I've taken these two vectors and I've added them together to get my new vector here. And you're probably wondering, isn't this the exact same thing we can do by just doing that? Absolutely. It gives you the exact same answer. It's just a different way of doing it. What you're doing is you're converting everything into x's and y's. Now, once you find your x's and y's, how do you determine your direction and magnitude? Because all you have, excuse me, all you have is a resultant. And you know this point here is 15.21. I've got some kind of crazy color there. Let me try that again. We have 15.21, negative 21.99. But what you need to do is, once you have that new vector here, you do the same thing again. You make a right triangle. Once you have a right triangle, you can determine direction, you can determine magnitude. So you're breaking everything down into a whole bunch of smaller right triangles. Okay? Let's try to do an example here. Above east 10 degrees north at 10 knots. So it's east 10 degrees north at 10 knots. And we will make this triangle green. So here's that vector. I make an angle with my right triangle. There is that triangle. This is 10 degrees. This is 10. I do my 10 sine, and I get this side of my triangle 1.73. And I get this side of my triangle 9.85. Then I do my next triangle. South 20 degrees west at 8 knots. So I get to there. Now I need to draw my right triangle. It's always to the x-axis. And let me even change these a little bit. So we can see there's our original. So we can see our original sides. Over here, this angle was 20. So I need this angle here, which is 70 and 8. So I use SOHCAHTOA again, and I get this to be 2.73 and 7.51. Now, both of those are negative. So now my x's, 10, negative 2.73. And I get 7.27. I have, oops, sorry, that's not right. I added the wrong things. Let's try that again. I have 9.85 and negative 2.73. That gives me 7.11. And then I have 1.73 minus 7.51. So I get negative 5.78. So I now have my resultant, which is 7, negative 5, which is about right there. Now I draw my right triangle with that new vector, and I know my sides. This side is negative 5.79. This side is 7.12. Now I can just do Pythagorean theorem. And I get this side 9.17. So there's the magnitude of my resultant. And if I want to find the direction, all I have to do is find this angle here, theta, which is just doing SOHCAHTOA, and I'm able to find my direction. This solves this problem the exact same way as the way we did it before. Both of these ways are used if you go to physics, so we're just trying to show you both ways. Some people prefer right triangles. They want SOHCAHTOA and they do all right triangles. Some people prefer law sines and law cosines. Both get you the right answer. This method with the triangles is much better as your triangles or your number of vectors gets harder. Imagine you have 2, 3, 4 vectors you're trying to work on. Doing it this method, you just find your x's and y's for each one, add them up. With the other method, you have a nasty looking picture to try to keep track of. So both of them have their place. They're just different depending on the problem. All right, next, homework over component vectors.